Here's the frame game for today. The one from last week was shouting at the top of my lungs, if you didn't figure that out. This video is going to cover 9-2, which is ellipses, the third of the conics that we're going to cover in this chapter. So what is an ellipse? An ellipse is like an oval, basically. Okay, it's a set of all points x, y in a plane, the sum of whose distance from the two distinct fixed points, which are called the foci, is constant. So the sum of the distance, meaning I'm going to add the distance from one to the other to get that constant oval shape. The line through the foci intersects the ellipse at 2 points called the vertices. So if you look at the shape that's here, here's my original ellipse, okay? These two axes, one is the major axis and one is the minor axis, and they intersect the ellipse at what are called vertices. And the chords joining the vertices is the major axis. So this one is called the major axis, okay? It's the longer axis. Its midpoint is the center of the ellipse. And the chord perpendicular to the major axis is called the minor axis. So the shorter one would be the minor axis, and these are referred to as co-vertices. So again, your ellipse has two axes. The larger of the two is called the major axis, and where that intersects the circle, or the ellipse, is called the vertex. And then it has the minor axis, and where that intersects, which is the shorter one, and where that intersects the ellipse are called co-vertices. The standard form of an ellipse looks like this. So there's a little bit more information. If the ellipse is centered at 0, 0, so if your center is on the origin, then it would either be horizontal or vertical. It's horizontal if the larger axis or the major axis is on the horizontal, which we'll talk about in a little bit how you can see that from an equation. And the shorter axis, the minor axis, is the vertical. That's a horizontal one, so it's wider than it is tall. The vertical ellipse is taller than it is wide. So its major axis is the vertical axis, and its minor axis, or shorter one, is the horizontal. They still both have major, minor, where the vertex occurs along the major, the co-vertex occurs along the minor. And then we have something called the foci, or focus is for an individual one, and that lies along the minor axis inside the ellipse. Along the major axis inside the ellipse. So if I look at the vertical one, here's my vertex and my other vertex. Here's my co-vertex and co-vertex. And then my focus is on the major axis inside my oval. Okay, so here's the equations for the ellipses. So this would be if your center's at 0, 0. We'll talk about a little bit what happens when that shifts off of 0, 0. But your equation is x squared over a squared plus y squared over b squared equals 1 for the horizontal. For the vertical, it's y squared over a squared plus x squared over b squared equals 1. Now, really, this could be interchanged. The order here is not important. The biggest thing is that a is the largest value. So if the largest number, a squared, let's say, is under the x, then it makes it a horizontal. If the largest number, which is under the y, then it makes it vertical. So whatever a is, if it's under the x, then we count out from the center to the right and to the left the value of a. Those are your vertices. Whatever b is, we count up and down if it's a horizontal one, because those would be our co-vertices. And the foci is along the major axis, so we go left and right from center, whatever the value of c is. You will be given two of these things. So if you're given the equation like x squared over 25 plus y squared over 9 equals 1, I know 25 is bigger than 9, so that would tell me that this is horizontal. And that a is 5 and b is the square root of 9, which is 3. So from my center, I know it's horizontal, which means I go right and left the a. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's my vertex. Up and down the B. 1, 2, 3. 1, 2, 3. And there's my ellipse. If I want to find the foci, then I use c squared equals a squared minus b squared. So it's close to the Pythagorean theorem, except that it's a minus. So I would say that c squared equals a squared, which was 25, minus b squared, which is 9. C squared would be 16. C itself would be 4. So I'd go to the right 4 and to the left 4, and that would be my foci. The length of the major axis is 2a. So if they give you the length of the major axis is 12, then I would know a is 6. And the length of the minor axis is 2b. So if they told me that let's say the length of the minor axis is 10, then I would know that b is 5. So this would change to a vertical if it said x squared over 9 plus y squared over 25 equals 1. So now the a is under the y, which would make it vertical. My a is still 5. My b is still 3. My center's still at 0, 0. So I would go up and down the a this time. 1, 2, 3, 4, 5. Down 1, 2, 3, 4, 5. And right and left the b. And then my focus would be 4 up and 4 down along my major axis. Okay, so what happens when my center's not at 0, 0? And for these, you'll see that you'll be adding or subtracting something within the parentheses. So if we keep similar to what we just did, we could say x minus 2 squared plus y plus 3 squared. We're going to keep this over 25. We're going to keep this over 9 for this example. So think about what's happening. We're taking the h now and adjusting it the a, because the h is no longer 0. So I would start by identifying my center, which is the opposite of what follows x, the opposite of what follows y. So it would be 2, negative 3. The a squared is still under the x, so this is a horizontal, where the a is 5 and the b is 3. So then I would plot my center, 2, negative 3, and instead of going right and left from the 0, 0, we go right, left from here. So I'd go to the right, 1, 2, 3, 4, 5, and go to the left, 1, 2, 3, 4, 5, and go up 1, 2, 3, and go down 1, 2, 3. And there's your ellipse. So if I wanted to find these coordinate points, I would take my original center. I'm adjusting the x's or count from the point that I had to where it is. And I would say that my vertex or my vertices are back here. We went left 5. So this would be negative. That would be 1, 0, negative 1, negative 2, negative 3. That should have been the point there. It's not really distanced correctly. And then my y stays the same. And then I went forward 5. So I would get 7, negative 3. And then the co-vertices, I went up 3. So that's going to change my y coordinate. And I went down 3 to the other y coordinate. And then my my foci, which we knew the c from before is 4, would be here and here, which would be 6, negative 3, and negative 2, negative 3. And then what changes if my equation is switched, let's say it stays this way, is the larger's now under the y, which means this is vertical. So I would plot my center, 2, to negative 3, sorry, here. And I would go up and down 5, 1, 2, 3, 4, 5, down 1, 2, 3, 4, 5, right and left 3. And there's that ellipse. So that's the difference between the vertical and the horizontal. In the horizontal, the A is underneath the X, or the bigger numbers underneath the X. And in the vertical, the bigger numbers underneath the Y. Okay, example 1. Find the standard form of the equation of an ellipse having a foci at 0, 1, and 4, 1, and a major axis length of 6. Okay, so for me, sometimes it's easier to graph it, so I'm going to start there. I'm going to say 0, 1, and 4, 1 are my foci, which means the midpoint between these 2, 0 is going to be my center. So HK is 2, 1. So the distance between my center and the foci is 2. That means C is 2. And that's all the piece of information I have so far. The other piece that they give me is that the major axis length is 6. So the major axis is 2A equals 6 and A equals 3. Now I have C, I have A, and I know that the foci is here and here, which means this has to be a horizontal ellipse, which means the A is going under the X. So I'd get X over 3 squared, and the X gets the H. So X minus 2 squared over 3 squared plus Y minus 1 squared over, now I've got to find B. Remember, C squared equals A squared minus B squared. So 2 squared would equal 3 squared minus B squared. 4, 9. Subtract negative 5 would equal negative B squared. So B squared would be 5. Which I can say B is the square root of 5, but when I plug it into the equation, I'm going to square it anyways. So you don't even have to go that extra step. I get X minus H squared over 9 plus Y minus K squared over 5 equals 1. So the ellipses always equal 1. That's the standard form of your equation. Okay, example 2. Sketch the ellipse given by the following equation. Identify the center and the vertices. Remember what we just said, that this always has to be 1. So our first step is to divide everything by 36. So I'd get X squared over 9 plus Y squared over 36 equals 1. From here, I know my center is 0, 0. The bigger numbers under the Y, so this is a vertical ellipse. A squared is 36, which makes A 6. B squared is 9, which makes B 3. So I'm going to start at my center. And I'm going to go to the right. Sorry, I'm going to go up and down the A because it's vertical. So A is 6. I go up to 6 and I go to negative 6. B is 3. I go right and left B. And then I connect my points. Now it just said center and vertices. So my center I know is 0, 0. By vertices, it means vertices and co-vertices. Sometimes it will not say both, but it does mean both. So vertex, or the vertices, are here and here, which is 0, 6, 0, negative 6. And the co-vertices are here and here, negative 3, 0, and 3, 0. If it had asked for the foci, then I would have done C squared equals A squared minus B squared. 36 minus 9, 27, and C would equal the square root of 27, which is 3 root 3. So the foci is up and down. So square root 27 is a little bit bigger than 5, which means it's about here and here. Or 0 root 3 root 3 and 0 negative 3 root 3. But you didn't need the foci. I didn't ask for it this time. I just went over it just in case it does ask for it. Okay, example 3, graph the ellipse and then identify the center, vertices, and this time foci. So here's the super fun ones because these are not in standard form at all, which means we get to complete the square. And just like with the circles, there's 2 variables that need the square completed, so we're going to do it twice. So I'm going to group together the x squared, the 6x. I'm going to leave the space for what I have to add in. I'm going to group together the 4y, the 8y, leave where the spaces I need to fill in, and bump the 9 to the other side. Okay, so from the first one, I can just take 6, divide it by 2. That's 3. And 3 squared would be 9. So I'm going to add that here and also to the other side. For the second one, I have to first take out the 4. So this would be x plus 3 squared. This one, I have to take out the 4 minus 2y. And then take the 2, divide it by 2. That's 1. 1 squared is 1. So that's what I'm going to add here. Before I add it over here, like I usually do, I have to multiply it times the 4. So I'd get 4 times 1, which means I'm going to add 4. So then this first one stays x plus 3 squared. The next one would be 4 times y minus 1 squared. Negative 9 and positive 9 cancel out, and then I'm just adding on the 4. So I'm almost there, but it's not standard form yet because this is not 1, which means I have to divide everything by 4. And I get x plus 3 squared over 4 plus y minus 1 squared over 1, because the 4 would cancel, equals 1. Now we technically don't need this 1, but we do want to remember that that's something that's underneath the denominator because it's either going to be the a or the b. So, speaking of that, I know my center from here would be negative 3, 1. The larger number's 4, and it's under the x, which means this is horizontal. If a squared is 4, then a is 2. And if b squared is 1, then b is 1. So I can start there. Graph my center, negative 3, 1. I go right and left B, A, which is 2, 1, 2. And up or down B, which is 1. And there's my ellipse. My center is negative 3, 1. It's horizontal. My vertices are at negative 5, 1 and negative 1, 1. And my co-vertices here and here, negative 3, 2 and negative 3, 0. And last but not least, I need the foci. So I need C. Remember that C squared equals A squared minus B squared. C squared would equal 4 minus 1. C squared would equal 3, and C would equal the square root of 3. So if I was to graph that, I'm going to approximate that to be like maybe a 1.8 because it's a little bit less than root 4, which would be in this direction and this direction. But when I use it for my actual coordinate points, when I'm adding and subtracting that from the x value of my vertex, or sorry, of my center, I'm going to leave it as root 3. So it'd be plus root 3, 1, and minus root 3, 1. Those would be your foci. All right, example 4. Graph the ellipse and identify the center of the vertices and the foci. So here's another complete the square to practice, right? We're going to do the same thing. We're going to group them so the x's can get grouped together. The y gets grouped together. The 8 get bumped to the other side. Take the 4 off of here, and it's x squared minus 2x. Leave this space. Y stays the same way, leaving that space. Negative 2, ignore the negative, just 2 divided by 2 is 1. 1 squared is 1, add it here, but multiply it by the 4 before we add it here. Take the 4, divide it by 2, that's 2, square it, that's 4, add it here and add it here. I don't have to worry about multiplying anything because there's nothing in the front. So I've got 4x minus 1 squared after I factor it, plus y plus 2 squared after I factor it, equals 8 plus 4, which is 16. And then I need it equal to 1. So divide everything by 16. And I get x minus 1 squared over 4 plus y plus 2 squared over 16 equals 1. My center is 1, negative 2. A squared is under the y this time, so it's vertical. A squared equals 16, so A is 4. B squared is 4, so B is 2. So start with your center being 1, negative 2. Count up and down the A this time because it's vertical. So 1, 2, 3, 4. 1, 2, 3, 4. And right and left the B. 1, 2, 1, 2. There's my ellipse. So center is 1, negative 2. Vertices are at 1, 2, and 1, negative 6. Co-vertices are at 3, negative 2, negative 1, negative 2. And foci, c squared equals a squared minus b squared. C squared would equal 16 minus 4. C squared would equal 12. Square root of 12. So when we go to approximate it, we would do it from here. This is a little bit bigger than 9, but less than 16, which means it's going to be like a 3.4, 3.5. Somewhere around there. But when we go to enter it or add it onto our point, we need to make sure that we simplify that. So that's 4 and 3, which means 2 root 3. So now my foci, I'm going to take that 2 root 3 and I'm going to add it onto the y values because we're going up and down. So add and subtract from the y values of my center. So this would be 1, negative 2, plus and minus 2 root 3. So you can either write it like that or separate it out. Well, this song makes me so sad now. I don't know if you can hear it, but it's You Got a Friend of Me. All right, so there's my foci, vertice, covertice, center, and graph. Okay, eccentricity is also something that you can use on your graph. And basically the eccentricity of an ellipse indicates how oval the ellipse is. How flat it is or how close to a circle in shape it is. The variable that we use for eccentricity is E. Makes sense. It starts with the letter E. And it's given by the ratio of C over A. The eccentricity is always between 0 and 1. It can't be negative or less than 0, and it can't be bigger than 1. The closer it is to 0, the more it's shaped like a circle. The closer it is to 1, the flatter your oval is going to be. So the bigger the number, the flatter it is. The smaller the number, the rounder it is. So in these shapes right here, notice that C here, C over A is close to 0, which makes this pretty much like a circle. And this one, E is again C over A, but this time it's close to 1, which means it's more oval. So these questions will legit be just like part of what you had asked. So if I had gone back, so I just pulled in the screenshot of that last example. If it had, in addition to the vertex, the center, and the graph and all that stuff, asked for eccentricity here, I would say it's C over A, which in this case, remember my C was 2 root 3, so this would be 2 root 3 over A. My A was 4, and then I can just reduce that to be root 3 over 2. So it's just another piece of information they can ask you for. It's also another piece of information. Let's say they gave you just A, or the major axis, as a piece of information, and it gave you the eccentricity. You could find C, and then from there you could also find B. So it's one of the pieces of information they could use to give you information about it to get your equation. Okay, sorry. That wraps up the 9-2 notes. So please take time to submit those notes, and then also submit your assignment for 9.2. Actually, I don't think you need to submit your notes this time. Just do the assignment for 9.2 on WebAssign and submit that before Monday. Have a great day, guys.